Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our string split function. This is part of our core C and core H library. And specifically, what we're going to be looking at is the ability to parse a string into chunks. And this is going to become useful in a number of examples in your future projects. If you notice on the right-hand side of my screen, I have a sample users.csv. And the idea here is that I want to be able to read in a line out of the CSV file using one of my other functions, and then be able to parse that line based on a delimiter. In this case, the delimiter that I'm interested in is going to be a comma. The idea being is that I'm going to separate my contents based on that comma delimiter. And right now I have that as a single character, although it could technically be multiple characters. We could utilize our string find function to do this. But for right now, we're going to assume that it's a single delimiter. And we ultimately want to update our chunks array. Now notice our chunks array is a two-dimensional array of characters. Specifically, we want it to be a two-dimensional array of strings. And so essentially the first index corresponds to the string or the chunk, and the second index corresponds to the individual characters within a chunk. So the idea here is that we want to be able to, in this case, we want to be able to return 4 chunks, one for each column. So you would wind up with the chunks array would have 4 strings in it. Now, to begin with, let's go ahead and set up some temporary variables here. We're going to probably need a contents length, or at the very least, a contents index. We can get away without the contents length by simply leveraging the end of string characters, since we're going to assume that this is going to be a string. We can also, we will also need a couple of other temporary variables, not the least of which is going to be our results variable. And before we forget, we might as well go ahead and return our results, and we'll go ahead and initialize it here. So our results are going to be equal to 0. And what do our results represent is essentially the number of chunks that we have found. So number of chunks found. Okay, so continuing on here, let's go ahead and create a couple more temporary variables. How about if we have a int chunks count, as well as, or actually, how about if we keep this consistent? We'll call this chunks index, and then int chunk index. And the difference is this is the word index, and this is the character index. In other words, of a particular word. Okay, so let's get started. The first thing that we want to do is we want to set up a loop, in this case a while loop, that's going to loop through each of the characters in our contents. So in this case, what we can do is we can simply say while contents index, while contents square brackets contents index not equal to end of string. And we'll come back and we'll modify this because we're actually going to have a second condition here that we want to handle, but we'll start off with this. So while contents square brackets contents index not equal to end of string, we want to look for our delimiter. Now, if our contents square brackets contents index, if that is equal to our delimiter, we have found a new chunk. Else, we append onto the old or existing chunk. So in this case, we're actually going to take a look at the else branch first because it's probably the easiest to understand. So let's go ahead and initialize a couple of our indexes. So we'll start off with our contents index, and our contents index is going to be equal to 0. Our chunks index, because remember that is the word count essentially. So chunks index is equal to 0. And then the chunk index, which is the individual character index. Now, before we forget, inside of our while loop, we always want to go ahead and increment our contents. Increment our contents index rather. And in the else branch, when we append to the old or existing chunk, that simply says chunks square brackets chunks index square brackets chunk index is equal to whatever the current character is we are looking at. So in this case, it's going to be contents square brackets contents index. Now, before we go too far, let's go back to our file real quick and make sure we understand what that means. So essentially, I'm starting off with an array and an uninitialized array because we have no idea what's happened outside of the array, outside of our function rather. And what I'm doing is I am coming along and I'm grabbing the first character, in this case, the capital letter M, and I'm saying, does it match my delimiter? And if the answer is no, then I am going into the two-dimensional array chunks at the 0, 0 location, and I am simply setting that value equal to the capital letter M. And then at this point, what I want to do is I want to increment the chunk index. Notice this is singular. And so essentially what I'm doing is I'm saying the next letter, next character that I receive, I want it to go in the next location. So then we loop back around using the while loop. I grab the Y in my last name. And if it does not match the delimiter, I come over to the else branch of the if statement. And then I am now putting it in 0, 1, and so on until I hit the comma. And when I hit the comma, then that means that I am matching my delimiter, assuming that's the delimiter that I was looking for. And we have found a new chunk. Well, what does it mean to find a new chunk? Well, there's a couple of things. Number one, we want to close the previous chunk. In other words, we want to finish it off. And the idea is that if I've given the function a string, I want to return or update an array of strings. So we need to make sure first to append to the current chunk. So chunks, square brackets, chunks index, whatever the current character index is, or chunk index singular, we want to set that equal to the end of string. So this makes sure that we use strings, or essentially that the chunks will become an array of strings. The next thing we want to do is we want to increment the chunks index, which essentially says we are moving on to the next word. Okay. And in order to move on to the next word, we want to take and we want to set our chunk index equal to 0. So this is the first character of the next word. Now, it doesn't mean that there is going to be a next word, but it just says that there is at least going to be room or assignment of an end of string, and you'll see why in just a second. Now, once we have looped through all of the characters until we find our end of string character, we simply want to update our chunks to make sure that we terminate that very last string by saying chunks square brackets chunks index. That's the plural. That indicates which word we're looking at. Or in this case, depending on the delimiter, it may be a string. So maybe word or words. I'm using that term word very loosely here. But this second index, then, the singular, is the individual character in that string. And we simply set that equal to end of string. And this assures or makes sure that the last string is terminated. And so just to make sure that I don't confuse anyone, I want to come up here and I'm going to change this to string, or at least mention here that it is a word or a string. So word or string. All right, so let's think about this to see if we've handled all of our scenarios here. So there are several scenarios you can think about, but let's start off with the simplest, and that would be that if the content simply has no characters in it other than an end of string character, in which case this loop will run 0 times, and you will essentially insert an end of string character into the 0, 0 location, and in which case then your results are going to be equal to 0. The second scenario would be that you got some characters, but you never found the delimiter, in which case all of the characters would merely be inserted into your first chunks. So the 0th row of this two-dimensional array. Perfectly fine. And then at the end, when you got kicked out of the while loop, you would simply append the end of string character. Now let's look at the scenario where, let's say I'm provided with my first and last name. We'll ignore the rest of the text. We'll assume that that's the end of the string, in which case I will loop through until I hit the delimiter, in which case I'll start a new chunks, okay, another new word or new string, resetting back to the 0th index for the second dimension. And I'll continue to loop then until I hit my end of string character. And because I'm appending an end of string every time I create a new chunks, then effectively both Myers and Gregory will successfully be strings. Now, the only thing that we have left to do is decide exactly what results do we, in fact, want to return. Now, we can return, for instance, the number of characters that we have counted, the number of chunks that we have returned. Either is perfectly fine. And then also you want to consider, does a chunk, does a single character, excuse me, a single word with no delimiter count as splitting anything? So those are a couple of decisions that you want to make there. But at the very least, you could consider perhaps dropping the results and instead simply return the chunks square underscore index. So chunks index. So perhaps in this particular case, we can just simply leverage the chunks index and do not need the results temporary variable. The last thing that we want to investigate is the chunk length max. And if you look in your core.h, you'll notice that we have a couple of constants. These are convenience constants rather, that we have created that we do need to be aware of. And that is our chunk count max, and that is essentially then the number of chunks that we expect to find. In which case, what we want to do here is, while our contents, square brackets, contents index not equal to end of string, and our chunks square bracket underscore index less than our chunk count max. And once again, this just assures that in case the caller of your string split function didn't intend for you to have a large array or a larger array than 20 columns, that you don't accidentally exceed that. You can replace this or do this differently if you want. The second thing that you want to handle is what happens if too many characters are inserted into a particular column. Well, regrettably, this one gets a little bit on the ugly side. And so that means that if somehow you have passed to this function a string that has a chunk that is longer than you had anticipated, in other words, that the individual chunk is longer than chunk length max, what do you do with it? Well, the reason I say this is a little ugly is essentially the safe way to handle this is to simply ignore it rather than overrun your allocated memory. And to do that, what we do is we have another if statement inside of our else. So if our chunk index is less than our chunk length max minus 1, then what we want to do is we want to append the existing chunk. Well, what happens if that's not the case? So in other words, in our else, well, we simply do nothing. In other words, the data is essentially lost. Now, once again, this is just a self-preservation technique, meaning that it keeps your array from being overrun. There are other ways to go about handling this, but this just makes sure that you don't overwrite some additional data. Now, let's think about this for just a second. So if our chunk length max is 1,000, then that means that this value right here is 999. And why would I stop at one early is that it allows for me to make sure that that last chunk, even though it might be too long, has at least enough room to put the end of string character on the end. So let's give this one a shot real quick. Let's go ahead and build it. Let's set up our main to see if this works. I'm going to go ahead and comment out my results here since it turns out we decided not to use it. Let's go ahead and build it one more time. And now let's come over here to our core driver and let's figure out what it's going to take to run this particular function. Now notice I only need to provide this one with a file name and a delimiter, or a string and a delimiter. So what I'm going to do to keep this one simple, this example simple, I'm going to go ahead and provide it with a sample string as well as a delimiter. And the switch that indicates which function we want to call. So in this particular case, we only need argc equal to 4 and our string compare I of our argv1 to be equal to /Stringsplit. Okay, and once again, we're just simply using the name of the function that we just created as a switch. Now, we're going to call our string compare, or string split function rather. Our string split function, we're going to pass to it whatever is in my argv2. Remember, argv1 is the switch that tells us what behavior or what function we want to call. And I also want to pass to it a delimiter, and I want to be able to specify that delimiter from the command line. And so my first indication, or my first gut feeling, would be to say argv square brackets 3. Now, I'm going to go ahead and build this real quick. And you're going to see an error. And specifically, essentially what's wrong here is that I have not provided to it the chunks array. So what we want to do now is we want to come up here to the top of our main, and we want to create another temporary variable. We're going to go ahead and call it chunks. And we're going to initialize it utilizing our constants here. So we're going to specify the chunk count max for our first dimension. And for the second dimension, we're going to specify the chunk length max. This is, quite frankly, huge, much larger than we need it to be. Okay, you would probably want to rethink this if you were to do this. But the main thing is now, as my last argument, I'm going to pass to it my chunks. Let's go ahead and build it one more time. And now we get another error, and this one's a little more convoluted. But what we want to do is we want to take a look at our function signature for the string split. And if you'll notice, the string split specifies for the second input argument a delimiter, which is a single character, and we are trying to pass it a string. So instead, what we want to do is we want to use dual indexes, and we want to specify that we just want that 0 index character of our argv square brackets 3. And if we build that, you'll see that we are successful. So note here that this indicates that the 0th character of our argv square brackets 3. Now, to see that we've actually done anything, we need to build a for loop. And so in this case, we're going to say for index equals to 0, index less than results. Remember that results tells us the number of chunks that we found, index plus plus. And oh, by the way, it probably wouldn't be a bad idea if we simply just printed that. So printf chunks, or we'll just call it results. That's perfectly fine. But we want to follow that up with a %d and a new line, and then also our results variable. What we want to do now is print out each one of the individual chunks so we can print them out as strings. So let's make a fancy format here. We'll say chunks square brackets %d, which will allow for us to tell which chunk we're printing out, is %s, and that'll be the value for that particular chunk. And then for the first placeholder, we'll simply provide the index, and for the second placeholder, it will be chunks square brackets index, and this will allow for us to print out the entire string. You could, of course, print out each individual character if you wanted to, but that would just require then the second loop. All right, so let's go ahead and build this. Good, we've got success. Now, before we run this, let's go ahead and update our help before we forget. The first thing that we want to provide is going to be the split that indicates we want to do a string split. So for our help, like with the previous examples, the switch that indicates the function first. Then what we can do is we can come over here to our sample users.csv file. We'll cut copy rather that particular line. Since there's no spaces in it, we don't have to worry about an extra set of quotes. We can do that if we needed to. And then for the last argument, then we simply want to provide a comma. That looks like a rather strange argument there. But since this doesn't have any spaces in it, that's going to be the index equal to 2 argument, or argv square brackets 2, and then argv square brackets 3 is going to be the comma. And we'll go ahead and build it one more time. I see we've missed a semicolon here. Let's go ahead and build it again. And now let's see if we've got this working. So we'll start off with our core demo.exe. We'll provide it with the /Stringsplit switch, indicate which function. I'm going to go ahead and just drop in that particular string, and I want to indicate that we're separating it by commas. And you'll see that we have got 0, 1, 2. However, we did not pick up that last argument right there, excuse me, that last parameter. All right, so we have to think about why. So we could start by debugging this. That would probably not be a bad thing to do. We could also troubleshoot this by putting some printf statements in there. But let's first think about this for just a second. So if you take a look inside of our string split function, you'll notice that we are only incrementing the count of the chunks index after we have started a new chunk. That does not get triggered when we initiate or exit the while loop based on the end of string characters. So the question then becomes, how many chunks are we actually returning? And I'd mentioned this earlier because it was something to think about. In other words, if you are returning, even if it's one chunk, in other words, you did not find the delimiter in the target string, so in your contents, you did not actually find your delimiter, then effectively you are returning one chunk. The entire contents is now a chunk. So what you want to do is you want to think about what value do you want to return? Are you returning the highest index or the number of chunks that you have found? And so in this particular case, what we actually want to do is we want to return chunks index plus 1. And so if we build this now, if we come back over here to the command line and we rerun it, you'll notice that I am now getting this last argument. Now, I keep calling these arguments. My apologies if I'm confusing you. This is not meant to be a command line argument. I'm referring to these columns in this line of the CSV file. So this would be the 0th string, the first string, the second string, and then the third string in our chunks array. So essentially this is chunks square brackets 0, chunks square brackets 1, chunks square brackets 2, chunks square brackets 3. And sure enough, you'll see that there are my individual chunks. And notice that I do not have to specify the second dimension because I am printing them out as strings. If I wanted to print them out as individual characters, I would simply come back to our main and I would put a second loop in here that looped through until it saw the end of string for an individual chunk. So hopefully you've found this video useful. As always, if you have any questions or comments, don't hesitate to email me. And also you want to go ahead and get this function working because we will need it. This one was absolutely pivotal for future projects. So this particular string split function, you need to get working, as well as your other string functions in your core.c. Now, the only thing we have left to do are some of our exports. We will also add some additional functions in later videos, but our file functions, our file read and file read line, as well as some of our basic string functions are now all complete. As always, if you have any questions, don't hesitate to email me, and thank you for watching.